Hi, my name's Will Krozik, Scientific Services Manager at Chemical Computing Group. Today I'd like to show you the small molecule builder. The builder can be accessed directly from the right-hand side button bar in the main Mo window. The molecule builder can be used to build or modify small molecules. Here I find commonly used atoms, bonds, charges, stereochemistry settings, functional groups, and ring systems. The bottom section allows for exploring tautomeric states, performing energy minimizations, and a fragment tool for exploring the possible substituents at one or two attachment points using a fragments database. In today's example, I'd like to show you how to build didanosine from scratch. I'll start by attaching the builder to the main Mo window. To start building, I have the option to enter or paste a SMILE string, a chemical ID or chemical abstract search number, or I can type the chemical name prefixed with a question mark to search PubChem, eMolecules, and Chemical online sites. However, today I'd like to build this molecule from scratch, so I'll not be using this option. Instead, I'm going to start by selecting a cyclohexane. I have the option to add a name and tag for this new molecule, but I'm going to leave these blank for now. And now we have our molecule consisting of just the ring in the main Mo window. Next, I'd like to create a fused ring. I'll do this by first selecting the bond that I'd like to fuse to, and then selecting the ring that I'd like to fuse, in this case a 5-membered ring. Next, I'd like to change the atom types to replicate our design goal. To do this, I'll first select the atom that I'd like to change. Note that the selected hydrogen is highlighted in blue in the builder. I'm going to change this to a double bonded oxygen by clicking the relevant button. I'm going to continue to change atom types, and I can do this one at a time, or I can hold down Shift while I click so that I can select multiple and change them all simultaneously. I'm also going to change the bond order by selecting the bond that I'd like to change and then clicking on the double bond button. Again, I can do this one bond at a time, or I can shift click to select multiple bonds. I'll then minimize our system by clicking minimize. From here, I can go ahead and add my 5-membered ring. Here I'm going to change again the atom types, a carbon, this time for an oxygen. And to complete the structure, I'm going to add a methyl before adding a hydroxy at the terminus. Our structure is now complete, allowing us to refine our design intent for things like stereochemistry and tautomers. To investigate the different tautomeric states, I can go ahead and just double-click any atom to select the entire molecule, and note that the tautomers button becomes active. When I click it, I can view the different tautomeric states. The first tautomer is the current tautomer. However, I can select an alternate tautomer state by clicking on it. I'll just return to the original tautomeric state. Next, let's look at the stereochemistry settings for this molecule. For this, I find it useful to toggle on the 2D ligand display. And here I see that this particular ligand has 2 chiral centers. If I click one, the builder stereochemistry buttons will reflect its state. Green means that the selected atoms are not constrained, meaning that they can flip. Blue means they are constrained, meaning that they can't flip. Red would indicate that the 3D coordinates disagree with the constraint. G sets the chirality constraint to the current 3D geometry. X removes the chirality constraint, and I inverts the chiral constraint and 3D geometry of a stereocenter. If I wanted to add a constraint, I can do so by clicking on the R button. And when I do so, you'll notice that it becomes blue, indicating the presence of a constraint. I noticed that I need to modify the second stereocenter from R to S, so I'll do this by clicking the desired S button. When building, Mo will add elements at an energetically favorable position. But I can control the dihedral by selecting a bond and using the rotation wheel on the footer of the MAINMO window. Although our ligand does not contain a charge, I'd just like to show you how we would modify a charge on this hydroxy. I'll do this by adding a negative charge. In this case, a charge is not required, so I'll just undo that operation. I'll just complete the process by performing an energy minimization. And that brings us to the end of today's session, where we use the molecule builder to build and modify atoms, bonds, ring systems, and functional groups. We saw how to control dihedral angles, stereochemistry, and tautomeric states. Although not covered in today's session, the molecule builder can be used to explore possible substituents at 1 or 2 attachment points using the fragments database. If you have any questions, please do reach out to us at support@chemcomp.com.